Hey, this is Mrs. Weethy back for Lesson 5 in Stoichiometry, where we're going to be using molarity and density as our two new conversion factors. So our learning goals are basically the same. You will be able to determine the quantity of a substance in a chemical reaction using either the molarity or the density as one of the conversion factors. Now, it can be in combination with formula mass and always with the mole ratio. So let's get started. What is molarity? Molarity is a term that is used to express the concentration of a solution, and the units of molarity is moles per liter, but it's never written that way. It's always abbreviated as a capital M. However, when you're doing problem solving, you want to change the capital M into its units, which are moles over liter, and that would be 1 liter, which is equivalent to moles over 1,000 milliliters, since 1 liter is equal to 1,000 milliliters. We will most likely be using moles over 1,000 milliliters all the time. That will save us a conversion. So here's the first problem. We have 50.0 milliliters of a 6 molar sulfuric acid solution, and it was spilled, and solid sodium bicarbonate, which is baking soda, is to be used to neutralize the acid. How many grams of sodium bicarbonate must be used? Well, the first thing that you need is a balanced equation, and this is the equation we're going to work with. So, first of all, let's talk about where molarity fits into the general plan. You have now 3 conversion factors: formula mass, which you know you can convert between grams and moles; mole ratio, which you always have to use in stoichiometry to get from moles of A to moles of B. This is our setup for mole ratio. Now we're using molarity, moles over 1 liter or moles over 1,000 milliliters. There's a lot of different plans that I could show you, but I'm going to show you 3. Let's say that we have milliliters of A. Well, if you have milliliters of A, look, what's the only thing with these 3 conversion factors, what's the only thing you can convert to? Yes, I'm playing Dora. You can convert to moles. So we can take milliliters of A to moles of A, and then from there you go from moles of A to moles of B. But if you know the molarity of B, you can take moles of B and convert it to milliliters of B, okay, using the molarity. Another example, let's say you have grams of A. Well, you know you can take grams of A to moles of A, then moles of A to moles of B, and then using the molarity, moles of B to milliliters of B. Another situation, moles of A to moles of B, moles of B to milliliters of B, using the molarity. So you have to know what these units are. Don't just toss the units away. You have to work with them. All right, so back to the problem. We have our given quantity, 50 milliliters of sulfuric acid. We have the molarity, which is 6.0 capital M, but that's equal to 6.0 moles over liter, or 6.0 moles over 1,000 milliliters. And our unknown is grams of sodium bicarbonate. If we take a look at our plan, you start with the given quantity. This is our given quantity. Milliliters of sulfuric acid. Use the molarity. We have right here milliliters and moles. Molarity to convert to moles of sulfuric acid. Moles of sulfuric acid, so this is moles of A, to moles of B, moles of sodium bicarbonate, and then moles of sodium bicarbonate, 2 grams of sodium bicarbonate. And that last part, okay, these last 2 steps is what you're familiar with. All right, let's solve. Starting with our given quantity, we have 50 milliliters of sulfuric acid. We're going to multiply using the molarity, 6 moles over 1,000 milliliters. Milliliters divides out. Then we're going to multiply by the mole ratio. We are going to divide out the common units. And lastly, multiply by the formula mass of sodium bicarbonate. Divide out the common units. And there we go. 50.4 grams of sodium bicarbonate. Want to say that it's easy, but it's your first time seeing this. Let's take a look at another example. We want to know how many milliliters of 0.102 molar sodium hydroxide solution are needed to neutralize 35.0 milliliters of a 0.125 molar sulfuric acid solution. So now we're going to use the molarity, and both are given and are unknown. Balanced equation. And let's get in our given, our unknown, and our plan. So our given 0.102 molar solution, which we're going to change to moles over 1 liter, 35.0 milliliters of sulfuric acid, and the molarity of sulfuric acid, 0.125 moles per liter, which is equal to 0.125 moles over 1,000 milliliters. Our unknown is milliliters of sodium hydroxide. Plan. Start with your given quantity, okay, and your given quantity is milliliters. So milliliters of sulfuric acid, use the molarity to change that to moles of sulfuric acid, to moles of sodium hydroxide, to milliliters of sodium hydroxide. So look at this one. There's no grams anywhere, so you don't have to calculate the formula mass. All right, so let's solve. Start with the given quantity. 35 milliliters of sulfuric acid. Use the molarity to change to moles. Divide out the common unit. Use the mole ratio to go from sulfuric acid to sodium hydroxide. Divide out the common unit. Okay, and last, use the molarity of sodium hydroxide to get the milliliters. Divide out the common unit. Okay, now we did a shortcut and we used 1,000 milliliters of sodium hydroxide instead of liters. That way we don't have to convert liters to milliliters at the end. Multiply, divide, 3 sig figs, we have 85.8 milliliters of sodium hydroxide. Okay, so now it is your turn. This is the problem. How many grams of copper are needed to completely react with 50.0 milliliters of a 0.10 molar solution of silver nitrate? One product is copper 2 nitrate, the other is silver. So pause this video and do the problem, just like in the previous video. So do that and then come back to the video and look at the solution. Okay, so now that you're back, let's take a look at the solution. Balanced equation, given, unknown, and plan. And now the solution. And now, the final answer. Oh, after we divide out the units. How awkward. There you go. 0.0158 grams of copper. All right, that's molarity. Let's take a look at density. Density, we know, is the amount of matter, mass, in a given amount of space, which is the volume. The formula for density is mass over volume, and the units is grams over liter, or we can have grams over milliliter, grams over centimeters cubed. Any gram per unit volume. But nonetheless, 2 units, therefore it is a conversion factor. It allows us to convert between mass and volume. Density is usually used when working with volumes of gases. Here's the problem. How many liters of carbon dioxide are produced from the decomposition of 10.0 grams of copper 2 carbonate, where the other product is copper 2 oxide? The density of carbon dioxide is 1.997 grams per liter. So look, you have to get carbon dioxide in grams, because that's part of the unit of density, to be able to convert that to liters. So that's what we have to think about when we're making our plan. First, we need the balanced equation. And it's already balanced. Given 10 grams of copper 2 carbonate, 1.997 grams per liter is the density of carbon dioxide, but the unknown is liters of carbon dioxide. So let's start with our plan. You have to start with the given quantity, which is grams of the copper 2 carbonate. We can convert that moles, which we know, and then moles of copper 2 carbonate, we can go to moles of carbon dioxide. Now, from moles of carbon dioxide, we can convert that to grams. Remember I said we have to get carbon dioxide in grams in order to get that to liters. So moles of carbon dioxide we know we can convert to grams using the formula mass, and then from grams to liters. Okay, so you have grams of copper 2 carbonate, grams of carbon dioxide. You need the formula masses of both of those. Anytime you have grams, you need the formula mass. Let's solve. 10 grams of copper 2 carbonate multiplied by its formula mass, divide out the common unit, multiply by mole ratio, divide out the common unit, multiply by carbon dioxide's formula mass, divide out the common unit, and lastly, let's use the density of carbon dioxide, liters on top, grams on the bottom, to get the liters of carbon dioxide, divide out that common unit, and there you go, liters of carbon dioxide. That concludes lesson 5 for stoichiometry. This is Mrs. Weethy, so long for now.